Okay, so before the break, we were looking at functions which took I/O things as their arguments or part of their arguments. And we looked at, in particular, a function which took an instruction to produce an A and turned it into an instruction for producing a pair of A's, and it did so by running the instruction twice inside a do block. Now, there are some standard functions which are very useful, which are worth seeing the definition of. One of which is the function sequence, which takes a list of instructions and runs them all one after the other. In other words, it creates a new instruction by running each of the individual instructions in the list. But it doesn't return any particular result, so it doesn't care about what values are produced by the instructions you run. So if we take an example, there's a function print, which takes anything which is showable, anything which you can convert to a string, and sends it to the standard output. So it turns a thing into an instruction for displaying one of those things on the standard output. So if we, for example, print 42, it will print the value of the thing that we ask it to do. If we ask it to print something which is not showable, for example, a function, then it says, I don't know how to show something of this type. Okay, but anyway, it's just something we can use in small examples. So, for example, if we have a list with two instructions, that's a list which is I/O of whatever, I/O of nothing in particular. We can run sequence on that in order to produce, in order to run the first instruction and then run the second instruction. So we could have used sequence to, well, okay. So what's the definition of sequence? So let's define our own version. We'll give it this specific type. And how are we going to do it? Well, we're going to use recursion over the list argument. The base case being when you want to do a sequence of no arguments at all. So what I/O result should I return in that case? I'm going to return unit. Do the trivial computation. Otherwise, if it's an instruction followed by another bunch of instructions, then I'm going to do recursion by using a do block, and inside the do block, I will, let me start the whole thing on the next line. I'm going to run the instruction I, and then I'm going to recursively run the rest of the instructions. And that's the definition. Okay? Any questions about that? Okay, now it turns out that, in fact, this do notation is actually just syntactic sugar. It's actually not, it's just an extra bit of syntax that Haskell adds to something which is built on top of more primitive operations. And when you want to do something of type I/O or something, ignore the result and then do something else, then actually there's an operator, which is this one here. So this would have been equivalent to writing, instead of a do block, I followed by my sequence IS. We could have written that instead of the do block. And then you could see, in fact, what we could have done is use what kind of function. What we're doing is combining all the elements of this list using a combining operator and a base case. What function do we use for that? Combining function.
But we can write my sequence equal the operator?
No, the operator just applies one I/O thing and another I/O thing to get the third I/O thing. We need to do it between every element of the list. Nobody remembers the function, the pattern, the computation pattern for combining the elements of a list? It wasn't map. Map is a computation pattern for applying something to every element of a list. What was the computation pattern for combining the elements of a list? Fold. We had functions fold R. So this would be fold R with this operator and this base case. All right, I think you need to go back and have a look at fold R. What about this guy here? This is very similar, a little bit more complicated. The base case, in this case, we need to return a list of A's. So if we've got no instructions to compute, what list of A's can we return? Well, we can return the empty list. Otherwise, if we have an instruction followed by some other instructions, then the result will be what we get by doing a do. We compute the instruction, but we want to actually save the result. And then what do we want to do? Well, we also want to compute my sequence of the rest of the list. That's all very well, but we actually want to save that result as well, call that A2. The reason is because what we want to return as the result of the whole thing will be A1. Oh, well, let's call that A's. There's more than one A there, and there's a single A there. We're going to return the A followed by the A's. Okay? So this is the thing which takes a list of instructions for producing A and turns it into one single instruction for producing a list of A's. Okay? All right, with those examples, then you might like to, at some point, return to these examples and see if you can define the functions specified in this example. So one is to copy all the contents of all the files together, join them all together into a single, and put them into a single file. And the other one is a sort of for loop. Okay, I'll leave that as an exercise.